This meeting is being recorded.
Okay, guys, in yesterday class, we discussed about OSPF, sorry, EIGRP, right? So EIGRP, we did a summarization on how the EIGRP works. EIGRP is a distance vector protocol, and EIGRP does use a formula which includes the bandwidth and delay. So to calculate that, it uses the formula. So whichever has the lowest metric, that path is preferred. We discussed about the reported distance, feasible distance, stuck inactive. We discussed about how we can use a passive interface for EIGRP not to be in the neighbor share. We also discussed about what are the ways that we can configure EIGRP, like putting the network statements into the EIGRP and stuff like that. So that concludes our routing protocol, guys. There is the BGP, which is the border gateway protocol. We're going to discuss that maybe by end of the course, or as a path through CCNP. But the BGP is not in the syllabus for now. But in the interview, you might get BGP questions. But for now, let's move on to the course. But by the end of the course, maybe the last couple of classes, we'll talk some of the real-time topics more into that. But let's go to the services topic now. So we're going to discuss about network address translation, NAT, and also NTP, and see if we have some time for SNMP today. So let's start with NTP. Let me start sharing my screen. So today we're going to discuss about NTP, guys. NTP is network time protocol. So why we use NTP, guys? So we use NTP basically to have the synchronization of the time of network devices with a common reference time source. For example, let's say you have let's say there is a PC. This is a switch. And there is a router. Let's say this switch sent a packet, this PC sent a packet to switch, and switch sent a packet to the router. If the time on this router and switch not in sync, let's say the timestamp of this one will be, let's say it sent the packet at 9. If the packet on this comes at 10 o'clock, if the time on the router is 10 at the time, there is a mismatch of the packet coming from here, and it says that I received a packet at 10 CST. When it's sending the reply, it is sending the reply at 10:01 CST. So there is a mismatch of time, guys. So if that is the case, there will be a delay in the communication. For example, if I'm sending an authentication request, when I mean authentication, let's say I'm using my PC and I'm trying to log into my system. Okay, login. I enter my username, password. So this password need to be validated by maybe router. Okay, on the router, it has to validate the username and password. If I enter my username and password at 9 o'clock, and if the router shows 10 CST, there is a mismatch of times between the login attempt versus the login approval. So in those kind of cases, there is a issue in the time synchronization. To avoid these kind of issues, So to avoid these kind of issues, what we're gonna do, guys, we're gonna do the time synchronization. So this PC will talk to the NTP server, the switch will talk to NTP server, the router will talk to NTP server, and this server will send the time to the router, to the switch, to the PC. As a matter of fact, every network device or any server or any host, they all talk to NTP server in the network, and the time will be decided by this server. And how does this server will get the time, guys? This server will talk to public clocks, public NTP servers. So from the public NTP servers, your NTP server will get the time, and that time will be sent to the routers. So as I said, NTP is to synchronize the time to the network devices with a common reference time. So in the environment like network, it is very crucial that all devices operate on the same time, so that it can ensure proper network operation and also like logging or any troubleshooting, right? So that's why the NTP synchronization is very important. And there is also NTP is like standard protocol, guys. It's an internet standard protocol. What does that mean? Means, so there will be an internet time. For example, there is a clock. This is called, let's say, this is a world clock. World clock. So this world clock will have stratum value 1. Stratum is nothing but number of hops to reach the original time packet. For example, let's say there is one more NTP server. There is one more NTP server, and this is your PC. Okay. This is server 1. This is server 2. This is server 3. So stratum value 1 is the original time source, guys. So that way, that will be sent to this guy and this guy. This will have a stratum value of 2, because the original time source is this one, which has a stratum value of 1. They send the packet to this time to these two servers. The stratum will be increased to 2. So now that will be sent to this server, and the stratum value will be 3, and that will send the PC. So here the world clock will be sending the actual time. This is where all the people in the world will rely on this world clock, and from there you will be getting the time. So when you purchase a laptop or your phone, you will select the world clock, like in your time zone, like CST, EST, PST. You will select your time zones, and that time zones will be defined. Will talk to the world clock. So you will, when you have an internet connection, your phone automatically talk with this internet internet standard protocol, which is NTP. So NTP can be used to synchronize the time between devices across the internet. Okay, so that's how the NTP do the synchronization. Okay, and to configure NTP, guys, so what we're gonna do is, on the router, you will do like commands. You will go to router, and then you will do configure terminal, and then you're gonna do NTP server and define server IP address. That's how you will configure the NTP server with a server IP. Okay. If you want to use an authentication key, I mean like a user, like a password. For example, let's say there is a new device, new PC, and we don't want that PC to get the time from one of our server, NTP server. So to stop this PC to get the time, we will put what guys, password protection. So password protection is like protecting the NTP server so that everyone will not get the time from the servers. So to configure that, we can do like NTP and then define authentication. We'll configure that. So To see the time on the devices, we'll just do show clock. Is the command we will define to see the time of the devices. When you do the show clock, it will show you the NTP server that it is getting the time from as well. You can also do show NTP status. So that is the concept of NTP. To rewind it, NTP is a network time protocol. It is used to synchronize the time to the network devices with a common reference source. Any questions on NTP, guys? It's very simple, very basic concept. It's not complicated at all. Any questions? Is it clear, guys? Can you guys hear me?
Yes.
Yes.
Okay, cool. Just making sure. Did you guys understand the concept of stratum?
Yeah.
Can you tell the stratum value?
I'm sorry.
Can you explain again about stratum value?
Can someone explain what is stratum, guys? Sai Shri, can you try?
Sorry, even I'm not clear about that.
Anyone? Hari, can you try?
It is the number of hops from the world clock to the devices.
Yes, it is number of hops from the world clock to the actual device. For example, let's say this is a PC. And PC is trying to get the time from server. And server is getting the time from server 2. And server 2 is getting the time from the world clock. So the stratum value will be 1 here. Stratum is 1 because it is the original source. And the stratum value will be 2 because it learned from the original source to the second server, and this server will have the stratum value of 3 because it's learning from 2 other hops away. And PC will get that time from PC will get time from server 1 with a stratum value of 3. Clear, guys? So whichever original source of the time will have a stratum value of 1. As the number of servers keep on incrementing, the stratum value increases. That's the concept of stratum. Is it clear now? I think who asked this question? Dilip, you
Yes.
asked this, or Kanishk? Did you
Yeah,
answer?
yes, it's clear now.
Okay, cool. Let's move on, guys. Let's talk about NAT. NAT is network address translation. What is translation, guys? What is translation?
Converting.
Converting what?
Network.
No, I mean, in general terms, what is translation? If I say hello in English, It's hola in Spanish, right? It's translation. So it's converting from one language to the other language or something like that. So we are translating the language from one to the other, right? That is called translation. So basically that concept works similarly in the network, but the main reason of translating the networks is, let's talk about the private range and public ranges, right? Private IP ranges. 10.0.0.0 /8 172.16.0.0 /12 192.168.0.0 type for some reason my keyboard got stuck. Give me 1 second. Okay, I think it's a cursor issue. Okay, so these are the private IP ranges, guys. Meaning these are local to the network. Meaning these are not paid. These are local and can be freely used. For example, if I am owning a small company, I can use any of these IP ranges inside my network. But if this network want to talk to outside of the network, for example, to the internet, if this private IP range, if it wants to talk to something on the internet, the private IP ranges cannot talk. These private IP ranges need a translation. So, for example, I have 2 employees. And these 2 employees want to go to internet, meaning like they want to search google.com. Okay. So they need a public IP to go out of my network and to reach the internet. But to talk between them inside the company, they don't need the public IP range. They can use 10 IPs. Remember, when we are doing the lab, we use the 10.IPs because those are private IP ranges and they can be used without having any purchase. Whereas the public IP ranges needs a purchase. You need to go to Erin Space or if whichever country you are in, every country has their provider, and they will purchase the public IP ranges. But when you are using a home, for example, if you are in home, to go to the google.com, you are not purchasing any public IP, because when you ask your vendor, the vendor will come to your house, install a router, and they will on the router they will already put a public IP to go out to the internet, so that you are getting that public IP automatically. The router will give it to you. Meaning, so let's say you are in your home. Let's say you have Wi-Fi router, I mean a Wi-Fi device, and you are connected to your Wi-Fi, and your Wi-Fi router will already have a public IP defined, because you call to your AT&T guy, they came to your house and they installed a router, and that router will have a public IP that is allocated to you. And when you're going to the google.com, your IP will be what, guys? It will be translated. NAT will be automatically happen to go out to the internet, guys. So your private IP, whatever the private IP that you got, will be used to go out to the internet. So let me show that to you. Let me share my screen. Let's stop the whiteboard here for a second. Let me show you. Let's see. Okay, so if I do, see, this is 10.27.6.201 is my private IP. So when I am local to my machine, I'm getting this 10.IP, correct? But if I want to know my public IP, what I'm going to do is I can go to Google and then do what is my public IP. I can search that. My public IP is so 198.160.103.149. So that is my public IP. So as I said, the private IP will be transferred to the public IP to go to the internet. Similarly, on your laptop, guys, you can do the similar thing. You can do IP config or because I am using a MacBook, I did ifconfig command on my laptop. You can do IP config if you are using a Windows machine. That will give your public IP address, like 10.IP on your machine. And you can go to Google and then do what is my IP.com. That will detect your public IP, and that is the IP that you are using to communicate with the internet. So that process is called translation. So translating of private IP to the public IP is a method of doing the network address translation, guys. I'll stop share that and then go to whiteboard again. Okay. So there are different types of NAT, guys. Let's talk about source NAT, because we already talked about source NAT already, because here I am sitting in my home. Let's say my source IP is 10.0.0. Is my source IP, and I'm trying to go to google.com. That is my destination. Let's say the google.com destination IP is 8.8.8.8. Okay, and here what has to be translated, guys? Is my source will be translated, or will my destination will be translated? Which one will be translated?
Source.
Yeah, because my source is the private IP, it needs to be translated to the public IP. So here my source will be translated. So this is called, here in this case, source. That will happen. Okay, so my source, this IP will be changed to something like a public IP. For example, in this case, 198.160.100.103. So this is the source NAT. But there is a flaw in this, guys. Let's say I have a big company. Let's say I have a big company and there are hundreds of employees. Okay, and all of these employees want to go to internet. They all want to go to the net. In this case, I cannot buy public IP for each, because the public IPs are limited. We cannot allocate one public IP for each employee. For a company like, let's say, Google, there will be thousands of employees and they cannot buy thousands of IP addresses because every IP address will cost $25 monthly. So if I have, let's say, 1,000 employees, I cannot use $25,000 monthly for each IP. It is very expensive. So I cannot get 25, if I cannot use 25,000 just for procuring the IP address. It is very, very expensive. That's why there is a concept called NAT overload or PAT, port address translation. Let's talk about that. Let's say there are 3 users, R user, S user, and T user, and they all want to go to the internet. They all want to go to the internet. So let's say the user R IP is 10.0.0.1, 10.0.0.2, and from my router, I use let's say I wanted to go to so from my router, I have a public IP 198.160.100.103. So I have only one public IP, but I want to use this user, and this user to go to the internet. So what will be the source IP for this user, guys? For user R, what will be the source IP? The source IP will be 10.0.0.0.1, and the destination IP will be 8.8.8.8. So the source IP is that, destination IP is 8.8.8, right? So here, when this IP went to this router, the source will be translated to this IP 198.168.103. Similarly, when this goes here, the source will be translated to that IP. When this goes here, it will be translated to 198.168.103, and all of these routers will go to the google.com. But when the return traffic is coming from google.com, it will all point to this IP. Then how does this know which user to send traffic back, whether to go to here or go to here or go to here? How does it differentiate the traffic of each user? User R may go to google.com and search for a game. S user may go to google.com and search for something like a website that he want to do social media. And T user may wanted to go to Google and they do something like a banking. So everyone does different actions on Google. So how does this router will differentiate them? They will differentiate using the source port. So what is source port? Before we talk about source port, in this scenario, what will be the destination port, guys? Anyone can tell me, in this scenario, what will be the destination port? So we know the source IP, 10.0.0.0.1. We know destination IP 8.8.8.8. We have to know what is the destination port. Do you guys know what is the destination port in this case? Tell me, how does the destination port is identified in a communication? Managna, you want to try?
No, I don't know.
Sorry, your voice is very low.
I don't know.
Okay. Anyone?
Is it HTTP?
Yes, it's because of the HTTPS. So because of this, we know what port we will be using. HTTPS port is 443. If I am using HTTP, the port will be 80. So because I am using 443, it will be HTTPS. Good answer. So in this case, the destination port will be 443 because I am using HTTPS. So I know source (10.0.0.1), destination 8.8.8.8, source port, random high port, range of port, (10) 242 655 35. It can be any random. It can be any random port between 10242 65535 and destination port will be 443. Okay, so that's how, based on the source port and the destination port, this will know the communication is coming from this R user, coming from this IP, using one specific high port, coming to router and going to the destination. When the return traffic is coming, based on the source port number, it knows that the traffic is coming from 10.0.0.1 and it will reply that back to this user. So for any communication, this is a rule called 5-tuple rule. The 5-tuple rule contains source IP, destination IP, source port, destination port, protocol. What is the protocol here, guys? In this flow, what protocol is used for viewing the google.com page? Dilip, you want to try which protocol that we are using in this case?
No idea, so
Anyone in the class?
HTTPS.
Well, HTTPS is an application. The protocols are like either TCP or UDP. Which protocol?
TCP?
Yes, this is a TCP because we want to have a reliable communication between the source and destination. This is not something like a voice or video where we're going to use UDP. This is something like a TCP we use. So we want to get the content of the data of the google.com. So we use TCP here. Correct. So that is the 5-tuple rule. It will contain source IP, destination IP, source port, destination port, and protocol TCP. So in this case, to use multiple users, only one IP address, we use the source port information and the source IP. So every IP address will be translated to the public IP, but because of the source port number, we will identify that packet is coming from user R. So similarly, when the traffic is coming from 10.0.2, it will go to this IP, it will map a specific source port number, and that will be sent to the destination. And when the return traffic is coming, it comes to this source port, and this will point back to the actual source. That is called NAT overload or PAT, which is port address translation. As it uses port to identify the specific transaction flow, that is called port address translation. Is it clear, guys? Is it confusing? Any questions on NAT overload or port address translation, guys? Any questions there? Okay, let's move on to the destination NAT. So let's say you have a web server that you are hosting. Let's say you have your own company and you host a web server. Maybe let's say you hosted something like maybe a gaming.com company that you own it, okay? And there is a user that is sitting in the internet, and he's sitting in his home. He's sitting in his home, and he has a home router. Okay. So from his home, he gets a private IP to the public IP, and that public IP will be sent to your company, and your company should have a public IP, and that public IP will be transferred to the private IP. Okay. So this translation of public IP to the private IP is called destination NAT, because in this case, the user is coming and hitting your server, and your responsibility is to create a public IP transferred to the private IP. Because inside your network, you will be using a private IP for hosting this web server, and you have a router on the edge, and you have to create a destination NAT to convert this IP to this IP, because this gaming.com need to be accessed from the internet by the user sitting in their homes. So this is called destination NAT, because the source IP of the user, for example, the source IP will be 198.160.101.100, and you should be having a public IP. For example, let's say your public IP will be 12.12.12.12. Okay, and that public IP will be transferred to a private IP 10.10.10.1. So in this case, the destination translation is doing, but the source translation is not doing on your router. On your router, you are only creating the destination translation, but the source user will be translated at his public IP, public home. You are not managing this piece now, you are managing this piece because you own your own company. Any questions on the destination NAT? Okay, let's talk about the dynamic NAT then. Dynamic NAT means you have multiple servers, and these multiple servers need to get access from the internet from someone home. Okay, but because of this many number of servers, you don't have the capacity to manage with a single IP address. Is not because of servers are many web servers are there in your network, and all of this cannot be managed by single IP address. So in that case, what you're going to do is you're going to create a pool on the router, on the edge router. You will create a pool, and that pool will be used to select one IP from pool. For example, let's say there are 3 users. They all want to go to internet. You have your router. So they have their private IPs. Private IPs. So they all can be translated to one IP, the public IP, 198.168, IP. But what if there are 3,000 users? This IP cannot handle more than how many users, guys? So let's say 1024.265535. So let's say every user will be assigned a specific port at a time. So let's say this user is associated to 1024 port. Next user is 1025, 1026, so on 65535. Let's do the math. So 65535 minus 1024. 64 ports. So at a time, 64,511 users can have the same IP. But what if my network has 72,000 users? In that case, we cannot allocate one single port to each user because the ports are full. In that case, we need to have a pool, meaning in that pool, this user may pick one NAT public IP, or they may use a different public IP. So if you use a pool of IP addresses, user may select one IP or the other. That is called dynamic network address translation, because we are not manually mapping one IP to other IP, but we are creating a pool and we have multiple users that they can point to more than one IP. Is it clear? How does a dynamic NAT works? Tanishq, is it clear?
Not like, can you explain again? Your voice got break, little bit.
Okay. Who can explain dynamic NAT, guys? Mahit, you want to try? Hari, you want to try?
I mean, I'm not that clear on this concept, so can you explain to me?
Okay. Let's do one more time.
Hello.
Yes.
Yeah, I'll try so.
Okay.
In the dynamic net, you said the example in the real-time example, like if suppose there are having any 3 or 4 users and they're gonna connect to the internet, and by connecting to the internet, they're gonna have the router. Uh, if they are in the private IPs, it's okay. But when it comes to the public, it's a different one. And you said about the numbers, like if they have if some 3,000 users, the IP can't handle that one. Like if there are any more numbers, you said the 7,000, 8,000. At that time, we need to have a pool. It gonna use the dynamic network translation. That's it. I just trying.
Yeah, that is correct. So if there are many number of users, if one NAT IP cannot handle the entire flow of translation, then we will use multiple translated IPs. We will group them into one pool, and users may pick one IP over the other. Because you guys are not clear, let me explain one more time. Let's do a table first. Let's do a table. So source IP, destination IP, translated source IP, source port, destination port, translated source port. Okay. So let's say there are 2 users. There is a router and they want to go to internet. Let's say user 1 and user 2. The user 1 source IP is 10.0.0.1. The user 2 source IP is 10.0.0.2. Destination IP, they want to go to google.com 8.8.8.8. 8.8.8.8. Okay. Translated source IP will be 198.160.100.103. 198.160.100.103. Okay, so this user is this guy, and this user is this guy. They both want to go to google.com. They both got translated to the same IP. But the source port of this user will be random. For example, let's say this got picked with 1025. Let's say this got picked with 1125. Okay, the destination port will be 443. That is based on the protocol. So that is based on the application, sorry, HTTPS application, which is 443. The translated source port, meaning when this guy translated to this guy, there will be a random translated source port, meaning so 10.0.0.1 with the source port of 1025 will be translated to 198.160.100.103 with the translated port of maybe, for example, 444.444. Okay, this may be translated to. So even though the source IP is same, the translated port will be different. So when the traffic coming from this guy, it will be mapped to this IP, but the port will be mapped to 4444. When the return traffic is coming to the router, it will send to this IP with the destination port of this one. So this router knows, okay, this traffic is coming to this port. I'm going to send that back to this guy because 4444 is mapped to 1025. I'm going to send that to 100001. So that's how the mapping works. Do you guys understand until this part? Is it clear by looking at the table?
Yes.
Are we clear? Kanishka, are we clear till this point?
Yes, it's clear, but I have one doubt. How the translate source port number gets generated?
It's a random port. The
It's a
router generates
random?
it. It's a random port. It is called random source port. The range is 1024265535. That is a random source port.
And it will be unique, right?
It is unique per transaction. Yes.
Okay.
So let's say these users got incremented. Okay, now I have, let's say, 80,000 users. But my available ports are how many, guys? 1024265535. So the maximum ports I can use is 64511. So I can only use 64,000 users can use a single IP because my source ports are only 64,511 ports are available. But what if I have 80,000 users? I cannot rely on a single IP. So I had to increase the NAT to the NAT pool. So now what I'm going to do is I'm going to use two IPs, 198.160.100.103. I'm going to purchase a different IP, 198.160.100.104. So using these two IPs, now my ports got doubled, meaning I can use 64,511 ports on this IP. Similarly, I get another 64,000 ports for this IP. So I am using a dynamic pool for selection of the users. Is it clear now? Sayashree, is it clear?
Yes, Ravi, it's clear.
Okay. So we discussed about basic NAT translation. We discussed about source NAT. We discussed about NAT overload or port address translation. We discussed about dynamic NAT. We also discussed about the destination NAT. Okay, so those are the different types of NATs that you have to be understanding. So in the interview or in the CCNA, you will get questions like you have a web server and you wanted to access that from the internet. Which kind of NAT you will use? Those kind of questions you will get in your certification exam. Can anyone answer that question? If you have a web server and you wanted to access that from the internet, which type of NAT you will use?
Could you say that again?
Can you repeat?
Actually, I didn't understand the question.
Okay, I'll repeat it. So you have a web server. You are owning that web server, you own the router, and there is a user that he want to access your web server. So what kind of NAT you will configure on this router to reach this web server?
Destination NAT.
Yes, you will use a destination NAT because the source will be coming from outside of your internet to your network, and they are using your destination IP, and you will be translating that public IP to the private IP. So the answer is destination NAT. So those kind of questions you can expect. Let's say you are in the office or in your home, you wanted to access the internet. So which NAT you will use?
As there is only one user, is it like source NAT?
Yes. So if you want to go outside of your space, you will use source NAT. So even though if it's 1 user or 10 users, you can use the source NAT. But when you're using 10 users, you have to use a port address translation because the users have to have separate sessions, right? So you'll use PAD there. But if it's 1 user, you can simply use a source NAT. So that's the basic difference. So keep those in mind and keep some bullet points so that you will remember the different types of NATs. Okay. I don't think we have a concept. We have time to go with the next topic, SNMP or syslog, because we are almost 10:02 now. So I'm going to leave the floor for any questions on these topics. Before I leave, let me ask some basic questions. Dilip, can you tell me what is NTP and why it is used?
NTP network time protocol to have the synchronous time devices across the network, sir.
Okay. So what is the reason to have the synchronous time on across all the devices? Why it is needed?
Why it is needed? Like
That's fine. Hari, can you try answering that? Why do we need the synchronization of time across all the devices?
the configure term, is it correct?
Sorry, I'm not following them. What did
The,
you say?
the configure term to configure.
No, the reason is, let's say, if you have a switch and if you have a router, and if the time is not syncing between both the devices, let's say the switch want to talk to a router, it sent a packet, but the router does not respond it back because it thought that the time that this switch sent does not matching to its time. So there is a mismatch of communication of time between them. Let's say you said hello to me, and what if I replied 1 hour after for your hello? So there is no point of you waiting for 1 hour. So there is a time synchronization issue between you and me. Similarly, in the network devices, to communicate better between the devices, for example, let's say you sent an authentication request, like you want to log into a device and you sent an authentication request to the authentication server. What if the authentication server is thinking that you are sending a request like 1 hour back and it is not responding to you now? So there is a time sync issue between both of the devices. To avoid those kind of conflicts, we use time sync between the devices.
Yes.
Okay. That's fine. Kanish, can you try what is a stratum?
Like it is the number of hops from the world clock to the actual device.
What will be the stratum value of the actual source?
Actual source will be the stratum value for the actual source means
So when the time is generated, what will be the actual source time? The stratum value will be 1, right?
one.
Because the device that
It will
has
be
the
1.
accurate time value, that will be 1. So in this
Yes.
case, the world clock stratum will be 1.
Mhm.
Okay.
Yes.
Okay. Hari, can you try what is a network address translation? Why it is used?
It is used to convert the private IP to public IP while communicating with a server outside the network.
Yes, so when you have a private IP and you wanted to access something on the internet, you will translate the public IP to the private IP so that that can be reachable over the internet. Manogna, can you try what is the destination NAT and why it is used?
So destination NAT is when a single user or when a user outside want to communicate with a particular, a private network. So the public IP will transfer the IP of the user to a private IP to access the destination address.
Yeah, so in this case, I think you're talking about a web server or a server that is hosted on the internet. If that wants to be transferred to the public to the private IP, then we will use a destination NAT. For example, if you want to go and buy an maybe phone, you go to Samsung.com. That Samsung.com will have a public IP, but the Samsung.com website will have a private IP inside their own network. So that transition will be done using the destination NAT. Sayashree, can you try what is a NAT overload and why it is used?
Yeah, sure. So it's nothing but when we have like multiple users, example, we have like 10 to like 20 users and they want to access the internet, they can use one like public IP over there, but in return when they're getting the result from the destination, so if you want to send that to that particular like private IP, so we have to use the like source address, destination address, and also the like source port and destination port. And the protocol which is used is TCP over here. In that case, we'll get to know which port is the one which is requesting for that particular information, and it will be sent to that particular user only.
Yeah, that is correct. So basically, when we have multiple users, to map that specific user with the specific port, we don't need to buy multiple public IPs. We can just use one public IP and we can map the users with different source ports. That is correct. That is what the NAT overload is. Yeah, I think that's it, guys. We have 7 more minutes.
Ravi,
I'm
I
going to
just
stop the
have a
recording.
question. Sorry.
Go ahead. Go ahead.
So NAT overload is nothing but port address translation, right? Like both are
Yes.
same.
Both are same. Yes.
Oh, okay. Okay. Yeah. Got it. Thank you.
Yeah. Okay, guys. I'm going to leave the floor for any questions, but I'm going to stop the recording. If you have anything, please ask me. If not, you are free to drop the class. Thank you.